morning, mathematicians. We are looking at week 21. We're looking at our Monday column. And let's start off with thinking about partial product and the area model method of dividing. So we know that what we are starting in this problem, dividing, is 936. So I have 936 this way. I know that I'm dividing that into groups of three, so I'm going to put my 3 here. Well, how many groups of 3 can I get from 900? I know I can get 300 groups because 3 goes into 9 3 times, and then I could carry up my 2 zeros. We can use our division with 0 tricks. We know that 3 goes into 30 10 times, and we know that 3 goes into 6 2 times. In this, I see my answer of 312. I'm going to go ahead and plug that in here to my answer box. And notice, boys and girls, everything here is to show how I have taken that dividend and given partial products along the way to divide. So really, boys and girls, what I started with here was 900, and I divided that by 3, and I got 300. This is what I'm seeing with this part. I'm going to do the next part in a different color, thinking about this 10. Really what I was doing was I was taking my 30 and I was dividing that into groups of 3, and I ended with 10. Now, lastly, I'm going to take a look at, I'm going to do this one in pink. I'm taking a look at where I got this 2 from. 2 or 3 went into 6 2 times. So really I was starting with 6 divided by 3, and I got an answer of 2. I'm looking at how that problem was solved with thinking about those quotients, thinking about the quotient being broken into those groups. Now let's go to the next part. We are also thinking about division here, but notice I'm going to solve one strategy or one A. I'm going to solve that here with the area model, and I'm going to solve B with partial quotients. Now, certainly you could solve this with your own chosen strategy, but we're going to arrive at the same answer. Now, when I'm asking myself how many groups of 6 can I get from this number, I can't get 100 groups of 6 because that would be subtracting 600 with, of course, it's going to be too big. I only have 522 to sort. So instead, I look at this and I know that 8 times 6 is 48. And if I make it 80, I can add a 0 here. And look how I've taken a good portion of that, but certainly I still have more that I can take. Notice that borrow regroup, and let's make sure that we're borrowing and regrouping carefully. We're going to have a difference of 42 here. So I'm going to let that 42 come and be my next column. And I'm going to ask myself, how many groups of 6 can I get from 42? I can get exactly 7 groups. 7 times 6 is 42, and I have no remainder. So my answer to this problem was 87. No matter what strategy you solve with, certainly we'll get to that same answer. Let's use B as an opportunity to think about partial quotients. 8 can go into 392 how many times? Well, what would be a good first take? I think about 40 because 4 times 8 is 32, and then I'm going to have that 0 carried over. Notice how that uses up a lot of this. I only have 72 as my difference. Now 8 goes into 72 exactly 9 times, and that uses all of this answer with no remainder. So my answer is 49. Boys and girls, if you use a strategy, you should arrive at 49 as your answer for B. Now we're going to go to our next 2 problems, which are great chances to take a look at how fractions can be shown in a base 10 grid and how that would translate to a decimal. Well, boys and girls, when I take a look at this one shaded box, I'm going to ask myself, how many total boxes are in this grid? That would be the denominator of my fraction, because the denominator is how many parts my whole is broken into. Well, I know this is a 10 by 10 array. This is a base 10 flat. So there are 100 parts to my whole. That's my denominator. My numerator is how many of those parts I have, and namely how many are shaded. In this case, I have 1 out of 100. So what fraction is shaded? It's 1 over 100. Now, if I translate that into a decimal, I'm going to remember that the hundredths place is 2 after the decimal. I'm going to put a 1 here because it's 1 out of 100. So there is 100. I could put a 0 in the ones place. That's an optional 0, not a mandatory 0. This one is optional. There's nothing in the ones place. This one is mandatory because it's pushing that 1 into that neighbor place value, the hundredths place. Let's use similar reasoning for our problem down below. The first thing that I need to think about is how many columns I have. Well, I have 1, 2, 3, 4. I have 4 entire columns. These columns are made up of 10 single pieces, so that is 4/10 of the entire grid. Now I'm going to ask myself how many singles I have. 1, 2, 3, 4. I have 4/10 and 4 singles. Again, I know my denominator will be 100 because there are 100 squares in this shape, and I have 44 that have shading because I had 4/10. Those are 4 columns. 40 individual squares in those 4 columns. I have 4 individuals that are a partial column that gave me 44 over 100. Now again, if I want to write that as a decimal, I'm going to remember that the hundredths place is 2 after the decimal point. I'm going to put my 44 there. And again, I can put my optional 0 in my ones place since there are no ones. With it, there's no ones. And even if I don't have that and just have decimal 44, there's still no ones. All right, boys and girls, we're going to look at this bottom problem. And this bottom problem is a 2-part question. Fill a plate. Owns the Pasta La Vista Bistro. Phil has 23 employees and each pays $520 per week. After paying his employees, Phil has $942 left. How much did he have at first? Boys and girls, when I am looking at a word problem, I want to read it multiple times. First, I'm just reading it for overall context. The next time I'm rereading it and I'm paying attention to what are these numbers in my problem. Sometimes they're actually in digits. Other times they might be words like dozen or triple or double. Certainly here I'm seeing 3 important numbers that I'm going to have to work with. Let's take a look at this sentence that I'm underlining. Phil has 23 employees and pays each $520 per week. When I think about that, 23 employees, each of them getting $520, I know that I need to multiply those 2 numbers together because I'm going to move to a pen that'll work a little better. I'm going to be giving them each $23. I'm going to put my 520 on top of my 23 as my bottom factor. And boys and girls, you know, in the Simmons room, we like to talk about these bottom numbers as divas. This number is the first diva. It knows the center of the multiplication universe. It's going to hang out with all the numbers above it. I'm going to ignore the 2 because divas don't like to share. First thing, my first pivot point is the 3. 3 times 0 is 0. 3 times 2 is 6. 3 times 5 is 15. That's when 3 is the diva. But then 3 is going to get dethroned. It is no longer the diva. It's no longer the center of this multiplication problem. And now the 2 is our next diva. Now 2 is actually sitting in the tens place. So my answer to 2 as diva has to start in the tens place. That's why we're going to put down a magic 0. We can call it magic, but really it's just math. I'm just thinking about the place value of the 2 and starting my answer in that place as well. Let's go ahead and let's think about 2. 2 times 0 is 0. 2 times 2 is 4. 2 times 5 is 10. And I've got a 1 over here. I don't want to forget that, even though I've got that kind of written over top of that dollar sign. 0 plus 0 is 0. 6 plus 0 is 6. 5 plus 4 is 9. 1 plus 0 is 1. And 1 plus nothing is 1. So we take a look and we see that to pay his 23 employees, he's going to have $1,960. Now we're going to turn our attention to the next sentence where it says, let me do this in blue. After paying his employees, Phil has $942 left. So to find out how much he had before he paid employees, combined with this, we have to add those values together. This is how much he paid. This is how much he had left after he made that payment. We're going to combine those things again to find out what he had before he paid everyone. 0 plus 2 is 2. 6 plus 4 is 10. Carry my 1. 1 plus 9 plus 1 is 19. There's my 9. Carry my 1. 1 plus 2, or excuse me, 1 plus 1 is 2. And 1 plus nothing is 1. 1, 2, 3, comma, put a comma after that mathematical period. And I have my answer. I'm going to put a dollar sign here because I'm going to remember that really this answer is the dollar value. The final question here said, how much did he have at first? So now I'm going to go back and I'm going to write my answer that at first he had $12,902. Quiz girls, that finishes our Monday